Hello, friends, and welcome to Lesson 4 of Unit 3, which is Diagnostic Analytics. I hope you enjoyed the last hands on practice. So, we'll continue with our Diagnostic Analytics today in MS Azure ML. So, today, what we are going to discuss would be causality. Number 2 is we'll take a case study on Volkswagen. Then, we'll do the concept of hypothesis testing, and then we'll do hands-on using our credit card example, and then we'll try to understand A/B testing. So that is what we have decided for today's lesson. Causality, as we were discussing in the last lesson about correlation coefficient, where which variable causes the other variable. So the correlation coefficient doesn't tell you that. Causality is something, for example, we have two variables x and y. So now we would like to know that which variable causes the variation or the change. So again, through the scatter diagram, as you can see, so it is decreasing. So there could be, if I see a scatter diagram like that, and I would like to know the causality out of this scatter diagram, there could be four possibilities. Either x is causing y, or y is causing x, or there could be no causality. It is only a statistical noise, as we were talking, only coincidence, or there is another variable z which is causing x and y. Since we are just trying to look at x and y, that is why we are getting this scatter diagram. Now for this lesson, for our class, what we'll be looking at from this scatter diagram and try to come out with is x causes y. That means if a relationship exists, the only possibility that we are looking at is that x is causing the y. And we'll focus on testing and quantifying the strength of the relationship. Whether when we say x is causing y, whether that makes sense or this is just a coincidence. So that is what we will be trying to see in this lesson. So quantifying the strength of this relationship. You need to understand the context outside data to figure out if x causes y. For example, if I talk about price and sales, as we have seen, there are a lot of factors. But if I talk of elasticity of price, so how elastic is the demand when we talk about the price. So you need to look at the weekly sales. As the price goes up, at the start of every week, the sales goes down. So in what context you want to use the causality. So that is very important. Now let me take up a very interesting case study which will give you the foundation for hypothesis testing. Now this is a practical use of diagnostics, or I would say how diagnostics help the authorities to pinpoint a particular company who was defaulting on the pollution level. And the company was smart enough and never thought that someone can find that out. And how a group of scientists were able to identify and pinpoint what Volkswagen was doing. If you remember, in 2014, Volkswagen emissions were questioned, and when they checked, later on it came out that they were befooling the authorities in terms of the pollution levels which were permitted, because the pollution level caused by Volkswagen was very high, whereas they were claiming it was less, and when it was being tested, so it was okay. So how they were how this fault was identified by a group of scientists through the diagnostic analytics. That is what we will try to see. Now, to give you the background, firstly, let me explain what really Volkswagen was doing. So, what they were doing, they had fitted a defeat device, which was a software in their cars, and this software was trying to detect when the road test, when the pollution test was carried out, whether that test is being carried out in the lab or whether it was being carried out in the field, right? So whether the car is in the lab or whether the car is outside on the road. So when they were testing the car, you have to go for the pollution test in a lab. So when you take the car to the lab, so this defeat device, the software was able to detect that you are in the lab. So it was controlling the pollution level and it was trying to have the emissions controlled to the permissible limit. But when it was outside the lab, so this defeat device was able to detect, and then they had lifted that emission level and it was emitting more and than the permissible limits, and it was giving a good mileage, so it was in a way beneficial to the customer, but it was defeating the purpose of the pollution level set up by the authorities. So the sum of the scientists, what they did, they did a study on this. So what these scientists did, they tried to do the test in the field, right? So what they did the test on a highway, and they did it on different places. Route 1, they had 5 routes identified. This was done in US. So Route 1 was on a highway, Route 2 was in an urban area, Route 3 was a rural hilly terrain, Route 4 was again another different city because of the climatic conditions, and Route 5 was again urban, was a different city. So they carried out the test in 3 different cities and also in the hilly and terrain, and also a smooth superhighway where there were not many disruptions. So that they can have enough data for their diagnostics. So once they did that, and they noted the emission levels, and then they run their diagnostics, and this is the graph which came out, and they had 3 vehicles, vehicle 1, vehicle 2 and vehicle 3. And if you look at this graph, the green line was the permissible limit, and they found that the emissions, average number of emissions, uh, uh, they were very high, right? So the ratio of the deviations, these were very high, as this green was the permissible level which was there. And whereas in the lab when these vehicles were tested, they were under the permissible limits. So they were very confused at why this is happening. Is it pure chance and this is all statistical noise, or this is a coincidence that this is happening? So it was not for just one vehicle, it was for vehicle A, B and C, even for C. This was there. So now they wanted to have a hypothesis, and they wanted to know that whether this is statistical noise, statistical variation, or it is true. So what they did, they calculated the spread, and if it is statistical variation, these red bars which you are seeing are the statistical variation. So taking that statistical variation into account, this is the lower limit, still it was very high, there was a big gap. So they were convinced that I think there is something wrong which is having, and they have enough good level of evidence to prove that Volkswagen, what they are claiming is wrong. So their chain of reasoning was that if Volkswagen is telling the truth, then we should not be seeing such high emissions. But if our road tests are showing extremely high emissions, way more than one can expect out of the statistical variation, then Volkswagen must not be telling the truth. And that is how the authorities caught the Volkswagen, and there was a heavy fine, and the CEO then resigned. So you know the consequences. So this is how the diagnostic analytics can help you in different business situations. Now, I gave you this case study because we would like to build a hypothesis which the scientists built for Volkswagen car emissions. So, why we use hypothesis testing? So, it is very important. The sole purpose is to know whether the variations that we are seeing, that is a statistical noise, is it a coincidence, or whether what we are claiming or what is claimed is right. Now, how we can use it? Statistical testing of claims about some population data. That is how we do the hypothesis testing. For example, when taking our new drug, so for example, a company is claiming that when taking our new drug, average reduction in blood pressure is 20 points. So this is a claim made by a pharmaceutical company, and we would like to check whether that claim is right. So what we do the statistical testing, or we do the hypothesis testing. Similarly, in marketing, if we say per dollar spent in advertising, if we spend $1 in advertising, the sales increases by $5. So I can do the sampling, I can take the data, I can do the statistical testing to verify the claim, whether this is a coincidence or whether this is right. So if we take the example which we had been talking about rise in the crime, because in a city, and why it is happening, because it is because of the electrical outages. That means the power is going off. So let us take that example to build the hypothesis. It is very important how you build the hypothesis. So crime in the city. So we have collected the data. We know where the power outages are there. Now, after collecting the data, we would like to build the hypothesis to check whether it is just a statistical noise, it is coincidence that these crimes are going up, or whether there is a clear relationship with the power outages, that whenever the power outages are there, that crime rate goes up. So how do you build this hypothesis? So we are going to talk about that. We'll take that as a concept first, understand that, and then we'll use the Azure ML to implement the credit card example for hypothesis testing. Similarly, we'll talk about the A/B testing, the concept, and then if possible the software. So let us build the hypothesis for the city crime example. Now, the historical data shows, and we know that the baseline average nightly crimes, which we know already, are 8.5 incidents per square mile. So in an area of 1 square mile, there are 8.5 incidents which are happening every night. So, and with a standard deviation of 5.2. So that is there with us. So we want to check that claim that when the electrical outages are happening. So we have taken the samples, and we have taken 40 such samples where the electrical outages are happening, and we have recorded the crime rate in those areas where these electrical outages are happening. So just to see whether this is normal, or whether when the electrical outages are happening the crime rate goes up. and what we observed was the average is 10.325. So I cannot say that no, the averages because of the outages uh, they increase from 8.5 to 10.325 in the areas where this is happening. Cannot say. So what I do is I try to see whether this is a coincidence or whether there is some strong relationship between the electrical outages and the crime rate. So either the crime rate is unchanged from 8.5 during electrical outages, or the crime rate is greater than 8.5 during electrical outages. So these are the two situations. We want to know which one is correct by statistically testing. So what we do, we build our hypothesis. So in the hypothesis, you have to have one null hypothesis and one alternative hypothesis. So we generally call it null hypothesis as H0 and the alternative hypothesis as H1 or HA. So the null hypothesis is that the crime rate is unchanged from 8.5 during electrical outages. So this is only a coincidence, and the average is 8.5. And what we are trying to prove after collecting the data of 40 samples, that no, there is alternative hypothesis where the crime rate is greater than 8.5 during the electrical outages. So remember, we can never say it is exactly this. So either it is greater, less than, or a range. So these are the hypotheses that you can build. So alternative hypothesis is always the things you are trying to prove. So here we are saying the observed difference, which we have checked statistically, is significant enough to be believed. And the null hypothesis, observed difference, is random statistical noise. So one of them is correct. Let us look at which one is right. How we do it, that is what we are going to do. So when we talk about the null hypothesis, so historically, average is 8.2, standard deviation is 5.2, so this is normal distribution. We would still see variation. So even if we stick to our null hypothesis, where the average is 8.2, 8.5, there is a spread of 5.2, so still we'll see an average of 10.325. So we would like to know whether it is significant enough, how much variation is there. So for that, we talked about probability in the last lesson, so it comes here, p-value. P-value is nothing, the probability value. So what we do is, if the crime rate is really unchanged, then we expect average to look like 8.5, standard deviation 0.82, but what we saw was 10.325 with the sample size of 40. So how likely is that what we are trying to claim, that is 10.325, is the average when there are power outages, and whether that is significant enough or not? So what we do is we calculate the p-value. So p-value means what is the probability of 10.325 within my normal distribution of 8.5. So there is a likelihood the p-value comes out to be 1.32. So 1.32% chance of observing average equal to or more than 10.325 if the crime rate was really unchanged. So this is the probability. Even if this is the average, we stick to null hypothesis. So within that, there is a probability of 1.32 of occurrence of 10.325 and more. So that is what we call as the probability, the p-value. Now how we interpret things? So that means we saw this and p-value is 1.32. So if this is 10.325, so this is around 1.32%. So what we do, how we decide, so we take what we call as a level of significance. So generally the level of significance we take is 5% level of significance, but this is a threshold limit which you can change, but let us say our significance level is 5%. So if the p-value is less than 5%, that means this 1.32 is not significant enough, within this, that is in my null hypothesis. So with 8.5 in the normal distribution, this is not significant enough, then we reject the null hypothesis. That means the occurrence of 10.3 to 5 and more is not significant enough, right? Then we reject the null hypothesis and we take the alternative hypothesis. So how we conclude? Crime rate is unchanged from 8.5, that was the null hypothesis. Crime rate is greater than 8.5 during electrical outages, that was the alternative. Now if the p-value is less than the significant level which is there, we reject the the null hypothesis, and we select the alternative hypothesis. Right? So with that background, let us take the example of credit card dataset. And we use MS Azure because this p-value, everything will be done by the software. Only thing we need to build is our hypothesis testing. We have to build the hypothesis. So in this, it is the same example. If you remember, long time back we did. So we segregated the data of credit card of 30,000 into high school and of masters. And this is the age, this number of observation for high school, and this is the limit balance for the high school clients, and this is for the masters. Now, what we would like to do is there evidence to support the following? What we are claiming? Average limit balance for customers with master's degree. So, average limit balance for customers with master's degree, we are talking of this, is more than 210,000 new Taiwanese dollars, so any currency. So is the average limit balance for customers with master degree is more than 210,000. This is a claim. So whether this is right or wrong, or it was a sheer coincidence when we checked the data. Because the average is 212,000, it is more. But is it statistically right? So can I claim, or it is just a random noise? Is it just a coincidence? So how we build our null and alternate hypothesis? Null hypothesis is average limit balance is less than equal to 210,000. And the alternative hypothesis is average limit balance is more than 210,000. So we have taken the random sample. You need to take that. Is the sample size large enough? These two questions you always, because it all depends on the data. So it has to be random sample, and it should be large enough to get the right inferences. So we have made our null and alternate hypothesis. Now let's work on MS Azure. So here you go. These were what you have done in the last lesson. You have applied the correlation to these. So we take the same example and we proceed from there. So we are using the SQL. So this is high school, this is masters, and we'll be using the t-test, as you know, for the hypothesis testing. So what we do is we type here hypothesis, right? We type here hypothesis. I get test hypothesis using the t-test. So it comes here, I drag it over here. I drag it over here below the SQL, not below this, but below the SQL. So I move this correlation thing to the left, and I drag it over here. Similarly, I drag another one over this, and I move this to the next side. So this is what I need to do. Once I do this, if you see here, so I say this is for hypothesis, and this is the test, this one. So I have moved it over here. After doing this, you need to fill in these. You need to fill in this. Now this is for the masters. Similarly, you can do for the high school. So I'm doing it for the masters. So, and then you connect with this. So you drag it over here, you connect it with this, and these are some of the values you need to put. The first one is the t-test type. So t-test type will be using a single sample test. So we have a single sample. So we pick a single sample set, right? So we pick that, and then the next one which I get is what is the value? What is the value? That is the null hypotenused mean. So I put a value. I put a value here which is 2,10,000. So this is what I want to check whether it is less than or greater than. So this is the null hypothesis mean that I want to test, right? Then the next one is, so the next one is target column. So in the target column, you pick the limit balance. In the target column, you pick the limit balance. Then the next one is that what is the hypothesis type? Hypothesis type. So we take one tail GT. We take one tail GT. What that means? One tail, we'll talk about that in the next lesson. But GT stands for greater than. So we always try to put here the alternative hypothesis condition. Alternative hypothesis condition. So our null was it is less than equal to 2,10,000, and the alternate hypothesis was it is more than 2,10,000. So I take one tail GT greater than here, and then the significance level which is the alpha, which is alpha. So the alpha is 0.05, that is 5% significance level. You can change. So once again, so this is single sample set, then 2,10,000, and then limit balance, right? And then one tail greater than one tail GT and 0.05. You need to check these because that is very important. This is for this test hypothesis using t-test. Once you have done that, then you run it. Then you run it. After you have run it, you get the tick marks here. And after you have done that, you right click on this and you go to the P test. You go to the P. Once you click on P, what you get? You get the P value. So what you get is P value is 0.0124, something like that, 0.0124. That becomes your P value. Then again, what you can do is you can right click here, right? You can right click here, and rather than P, you go to reject the null hypothesis. You click on this, so you get this one. Over here, you see it says reject. So this is true, right? So it is less than P values, less than the significance level. So you reject the null hypothesis. So it gives you that. So the Azure ML is doing it for you. And these are the results. We got 0.0124 as our p-value, which is less than the significance level. So we reject the null hypothesis. That means the average limit balance is more than 2,10,000 for the masters people. So that's what we have concluded here. Now this is a homework for you, and this homework is for one tail less than. So in this, the null hypothesis is greater than equal to 34.3. So we are trying to say here whether the age, right, is less than 34.3. If I go back, you will see that the average age is 34.3. And we are trying to say, no, the average age is less than 34.3. Whereas what we are getting over there is equal to or greater than 34.3. Now this is a homework for you. I want you to give me the p-value and the significance level you keep as 5%, and then you conclude whether this is correct or this is correct. So please do this homework and we can discuss in the next class what are your results. So let's also talk about A/B testing. What is A/B testing? In this, you have two populations. So you test the difference between two populations. Examples are the practical examples from the business. Is there a difference in medical outcomes between our new drug and a placebo? For example, like with the corona, the COVID-19 vaccine testing on humans, so that is what is going on. So we would like to check, we have developed a vaccine, a drug. So is there a difference in medical outcome between our new drug and a placebo? For example, I am creating these COVID-19 drugs, right, the vaccine. And I claim that yes, this vaccine is good for the COVID infection and it can safeguard you. So what I'm going to do is I will have two populations. Placebo means where I don't give the drug, that is one group, and the other is another group, another population where I give the drugs. So what I do is, so I then collect the results from both the populations in one without telling them that which group I am giving what. So in one, I give the same sort of packaging. So in one, there is simple water. In the other, there is a drug. So the one with water we call as a placebo. So then we check and see and build a hypothesis, A/B testing, and check whether the drugs have any effect on the population, or it is the same placebo and that is the same. Or sometimes the placebo may be better than the drug because there are some side effects of that. Second could be which website layout translates to more downloads of our application, design A or design B, two populations. Are sales higher when we get a celebrity endorsement? No endorsement, that population, endorsement, that population, and we do the A/B testing. So again, we use the p-value for this. So what we do in this process is define null and alternative hypothesis, collect random samples of data for A and B groups, use software to select appropriate tests, and generate the p-value and form conclusion and take actions. It is similar to the hypothesis testing. The only difference is A/B, either A is right or B is right. So we have two populations. So this is another homework for you which you need to do on A/B testing. So I'll tell you the homework, but let me explain another thing is in A/B testing you have paired or unpaired. So before that, what quantity you are testing, you need to decide that whether these are the means, proportions, variances, or something else. So there are two types, one is paired and one is unpaired. When we say paired, that means, for example, if I'm testing a drug with placebo or two drugs maybe. So what you do is, so in population A, the first person, so there is, I'm giving this drug to, and in the population 2, there is another person, and I match these two in terms of their age, in terms of their gender, in terms of their medical history, in terms of their height. So this becomes a paired A/B testing, where every member in population 1 is almost similar to the member in population 2. So we pair them. So in drug testing we do that so that we get the right results. But there can be unpaired, there could be many differences between A and B sets. Also the number of population is also different in population A and population B sets. So whether you're doing paired A/B testing or unpaired A/B testing. Now in our case for the credit card data set we have what we say unpaired. So it is not because on one side we are taking the masters and on the other side we are taking the high school. So this is not paired. So what we do is in how to use the Azure ML for this, we test of means unpaired sample sizes, set up in Azure ML, SQL queries as we have done for high school. We will continue with the same, add columns. So what you can do is you can extract the things through the SQL, and then you can make one database. You can join both the data sets for high schools and masters as one data sets, and you can take different fields. For example, from the masters, I've taken the fields as age M, that is age for masters, and in the high school, I've used age high school. So this field is here, this field is here. Then what I do, I can join the data sets and I can have 4 fields. So one field is age masters, one field is age high school. So we can do that also. So we will be using unpaired samples, and we'll be using one tail less than test in this case. And then we look at p-value and conclude. So what I want is, I have built the hypothesis for you for A/B testing. So what this is, so you have the same table here. So what we are trying to claim here is average limit balance for masters. Average limit balance for masters is $75,000 more than high school. So there is the limit balance. So if you see the difference, right? So this is 126, this is 212. So it is more than, so the this limit balance average is around very less than 75,000. So the difference is more than 75,000. So that is what we are saying. So whether this is right or this is wrong. So that is the claim, and we do the A/B testing. Whether A is right or B is right. So you need to build that, and let us see how you do this. So that's the homework 2 that you need to do. So let me summarize. It was a little bit bigger session, but it is good for you to have hands-on and do practice. The more practice you do, the more proficient you become in Azure ML, and hypothesis testing and A/B testing is very much used in the industry. So we looked today at causality. We looked at a case study of Volkswagen, hypothesis testing. We did the hands-on. We also looked at A/B testing. We didn't do the hands-on, which you are going to do, and you have homework 1 and 2, which we can discuss once you have finished that. Here is a small quiz for you. If the p-value is less than the significance level, what you do, you accept or you reject the null hypothesis. Question number 2. If the p-value, what p-value stands for? Testing the difference between two populations is what? If you have written your answers, please compare. If p-value is less than the significance level, you reject the null hypothesis. P-value stands for probability. Testing the difference between two populations is A/B testing. So friends, if you have any questions, feel free to write to me, or you can ask at any point of time. I'll be very glad to answer those queries for you. And these are for further reading if you want. These are 2 good articles on diagnostic analytics. And thank you very much for being such good listeners. And I once again request you to do hands-on. Without that, you won't be able to use MS Azure in the future. Bye for now. Shabba khair.